Okay, so I had a problem on my computer, so I had to stop that video. So our congruent statement will be triangle AGN is congruent to triangle, I'm going to space RTW. And that was because of the angle, side, angle. So angle, side, angle, which is a postulate. Let's see here. Sorry, it's not angle, side, angle. That's wrong. It's side, angle, side, which is right here. Side, angle, side postulate. SAS. There we go. Okay, let's continue. Model A. Oh, we just have some more. So this is for similarity. So now if we have two angles of one triangle are congruent to two angles of another, the triangles are similar. So remember when we talked about two angles, if we have a side, like let's say this side, then it'd be side, angle, side, and we know they're congruent. But if one side is different than the other, we know that they are just similar, okay? So, and you see the little sign here, this is how you write similar. This is the congruent sign, and this is a similar sign. So we have triangle ABG. Really hard to write small with my finger. It's congruent to CDE. Like so. Coming down here, side, side, side. So if the corresponding sides of two triangles are proportional, then the two triangles are similar. So this is when we do the numbers. So like FL is related to IP. If this were, let's say, 5, and this is 10. Well, that's a ratio of 1/2 or 2. So if that means that, let's say this one was, I'm going to make it a number, 12, sorry, not 12, 6. And this one's 12, that's still 1/2. And then if this was, let's say, 4 and 8, that's 1/2 or 2. So then our triangles would be similar. It'd be FLY. Over, do it in the same order. So we're doing blue to green. So it'd be PIG. Pig. One more, side, angle, side similarity. So if we have one angle from a triangle is congruent to one angle, so congruent is the same side. So we have same size. So these two. And two sides of each triangle are proportional. So this is two sides are proportional and one angle is equal. Then we have two triangles that are similar. So we have ACB, or let's do ABC. So along the black line towards the orange. So A, B, C. So starting at the green point, going to orange. So B, D, E, C. Okay, continue our model A. Name the two triangles that are congruent and state the theorem. So congruence. Let's see here. We got to try and figure out which ones have the same thing. So we have angle P and R with a side in between. On the next one, we have an angle T and U with a side on the outside. And then we have V and W with a side in between. So I think it's going to be PQR, that one, and that one are congruent because of angle, side, angle. Sorry. So PRQ is congruent to VWX because of angle, side, angle. This information that you know about the two triangles. So we know angle N, or AN, angle N is equal to angle W. We know side AN is equal to side RW. So AN side is equal to RW. And finally, NG is equal to WT. So can you determine the triangles are congruent or similar? If yes, write a triangle congruent or similarity statement and write the theorem postulate that supports it. So it looks like we have a side, angle, side. And let's just go confirm, see if we do have a postulate or theorem that proves that. Side, angle, side, postulate. So there we go, that's it. So, triangle ANG is congruent to triangle RWT. And that is because of side, angle, side. Okay, model A, list information that you know about the two triangles. Okay, so we have some numbers here. We're going to have to do some comparisons, some ratios. So it looks like our hypotenuse is 66. Well, we actually don't know it's a right triangle, but if we had this looks like it's a right if it is. We don't know that for sure, but I'm going to call it the hypotenuse just because it's the one that looks like it's the opposite of the right angle. So we have 66 and 13. I'm going to divide 66 over 13 and I get 5.07. So this triangle, or this side, is 5.07 times larger than that one. Well, that seems like we're not going to have a similarity in this triangle. Looks like it should be 5, which is weird. I feel like they should have made this. Huh. So because these are not exactly 5, like if this was 65 instead of 66, then this would be 5 times larger. Because 10 times 5 is 50, and 8 times 5 is 40. So these two sides are proportional. The third side is not. It's just a little bit off. So they are not similar. And it's because this last side is not proportional to the other two sides. And that was going back to side similarity postulate. Okay, so if they are all equal, then it's a similar triangle. But we have one side that's slightly not equal. Okay, so we cannot determine.